Good evening, 4th grade. I'm going to continue a little bit with what we did yesterday. So today we're going to represent and use multiples of unit fractions with number lines. We're actually going to work some of the same problems as yesterday. Just going to add a number line in the mix to see if that helps you understand it and gives you a better way to kind of show and represent what we're doing. So if you want, I'll give you a choice here. You can either find yesterday's we do. And if you have space to do some more work with those, to write some new things underneath or alongside those, that's fine. Or if you want to start a new page with this title, that's fine too. And just do the same examples again. So do one of those two things. Either find yesterday's if you have space or start a new page today. And after you have done that, unpause, close your notebook, and just concentrate and think with me. Alright, so yesterday we talked about this fraction first. We talked about how 7/5 can be represented as a multiple of this unit fraction, 1/5, as 7 times 1/5, and it is the 7th multiple of 1/5. And another way to show that simply today is with a number line. If I make a number line starting at 0, I can make all of my multiples of 1/5 are what I would normally put on the number line. Like if I was going to go from 0 to 1 to 2 by fifths by this unit fraction, when we partition the number line like we usually do, that's what we're putting on there is the multiples of 1/5. 3/5, third multiple, fourth multiple. This is the 5th multiple. This is the same as 1. The next multiple, we could either write 1 and 1/5 or 6/5. The next multiple, we could either write 1 and 2/5 or 7/5. 1 and 3/5 or 8/5. 1 and 4/5 or 9/5, and this is 2 or 10/5, either way. All right, and so that's a way to show the multiples of 1/5 on the number line, and you can just tell, first multiple, second multiple, third multiple, fourth multiple, fifth multiple, sixth multiple, 7th multiple, and that's where we can see the 7th multiple of 1/5 is right there, 7. All right, and it'd be the same as doing 1/5 times 7 would give us 7/5. So that's just a way to think about that. And then let's also look at our problem with the pizzas yesterday too to think about number lines. So we did this problem yesterday. Lisa invited a few friends to her home for pizza. 3 pizzas that Lisa's parents ordered were cut into 6 equal slices. When Lisa and her friends left, 7/6 of a pizza was left over. How many slices were left? And so yesterday we drew this with a diagram, drew the pizzas, colored in the parts that were left. And if 7/6 were left, that meant 7 slices were left, because 7/6 is 7 times 1/6. This is a slice here, and that's the 7th multiple of 1/6. So today I'm going to just erase the work there, and we can kind of think about doing the same thing with a number line. About orange. And so if I want to think about slices of pizza. So I would say she ordered 3 pizzas, so I'd probably make my number line go all the way out to 3 entire pizzas. Like that. And then each one is cut into 6 pieces, so they're cut into sixths. So my number line, I would have 6 on there. Actually, it's kind of boring, so I'm going to pause as I partition my number line so I don't waste your time here. And there you go. So there's all my partitions out on my 3 pizzas. I'll highlight, here's one whole pizza. You want to see that? Here's 2 whole pizzas. Here's 3 whole pizzas. And what I can do here, since 1/6 of a pizza is a slice, cut into 6 equal pieces, I can, my partitions on my number line represent a slice. This is 1 slice, 2 slices, 3 slices, 4 slices, 5 slices, 6 slices, and of course 7 slices, since they're 1/6, is going to end up at 7/6, which is where the problem tells me that's what's left over. So if there's 7 slices left over, there's also 7/6 of the pizza left over, because 7/6 is the 7th multiple of 1/6. So if we look at it here, this is the part of the pizza that's kind of left from here to here. And this is the part of the pizza, maybe I'll go with blue. And then this is from here to here, this is the part of the pizza that got eaten. So 7/6 are left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/6 of the pizza got eaten. 11/6, or 11 slices got eaten. Alright, so that's just how we can kind of use a number line to kind of think through the same problems as yesterday if the model or just the math language wasn't your preferred strategy. Alright, open your notebook. Let's go back to our other 2 examples from yesterday. So here's our first one. We wrote more than this, but I already erased it. We talked about the fraction 9/4. We talked about how that can be a multiple of this unit fraction, 1/4. It's the 9th multiple of 1/4 because it's 9 times 1/4. And so same thing, we can also just kind of show that on a number line. 0, 1, 2. I think it's going to be a little more than 2. And I would put 1/4, 2/4, 3/4. 1 is the same as 4/4. 1 and 1/4 is the same as 5/4. 1 and 2/4 is the same as 6/4. 1 and 3/4 is the same as 7/4. 2 is the same as 8/4. And 2 and 1/4 is the same as 9/4. And so this number line, now when I write them out like that, that shows me multiples of the unit fraction 1/4. That's all. Well, that's all the first 9 multiples of 1/4. So this is the first multiple, second multiple, third multiple, fourth multiple, fifth multiple, 6th, 7th, 8th, and 9th. So 9/4 is the 9th multiple of 1/4. And that's just another way to show it, another way to think about it, and another way to understand it. If that just makes it more clear to you, okay? So go ahead and write that down. Once you have done that, you can unpause and we'll do the next example about the laps in the neighborhood. So here is yesterday's version of how we worked this problem. Emma made a New Year's resolution to walk 4 miles a week by completing 1/4 mile loops in her neighborhood. After Friday is over, she has walked a total of 2 1/4 miles for the first week. How many laps does she need to walk to meet her goal over the weekend? And so we drew this with a model yesterday. We drew 4 blocks, each representing a mile. We colored in the 2 1/4 that she did. So 1, 2 1/4 are done in yellow, which meant to get to 4 miles, she had 7/4 to go. 1, 2, 3, 4, 5, 6, 7 1/4 laps to go. And since each 4th mile is a lap, that also meant she had 7 laps to go, because 7 times a fourth is 7/4. Okay, so that's how we did that yesterday. Let's show this another way today. This one, especially when you're doing like a distance, it's kind of weird to represent a mile with a block, but the number line is really sometimes kind of nice for distance questions. So what I want to do is I'm going to make a number line here, and I'm going to go up to 4 since she wants to do 4 miles. 1, 2, 3, 4. And I'm even going to give my number line like a title, I guess. I'll just say this is miles walked. And we want to go 4 miles, and she goes in 4th mile loops. So I need to partition my number line into fourths. 1/4, 2/4. I'm going to pause again and do this, and you can too. Just unpause after you've partitioned your number line out to the fourths. Alright, so there's my big old partition number line. I may highlight, just so it's easier to see them, there's 1 mile, 4/4. There's 2 miles, 8/4. There's 3 miles, 12/4. There's 4 miles, 16/4. Just so we kind of see where my mile markers are. And so in the problem, it tells us that during the week, she did 2 1/4 miles for the week, right? So she did, we're going to go up to 2 1/4 miles. Actually, you know what? I don't need to, if you're writing that, I don't need to write all these little things here. So she got to here from 0 to 2 1/4 miles during the week, right, is what it says. And so we know in the problem she needs to get from, alright, so that means for the weekend, got to get from there to the goal. Weekend in blue. So now, so the question, keep in mind, is not how far does she have to go, it is how many laps does she have to walk. So when I'm looking there, I'm saying, okay, well, she's got to go 1, 2, 3, 4, 5, 6, 7 more laps. Since we divided this into fourths, because a lap is 1/4 of a mile. So from my number line, now I can tell to get to her goal, she's got to do 7 more laps, or, 7 more 1/4. If you want to think about it, 7/4 more miles is 7 more laps. And that's how the number line can help us do that. I'll admit to you, if I were to pick my strategies back on the pizza example, I think doing the pizza example, the drawing makes more sense to me than the number line. But coming back to this example, when we're talking about a distance, I feel like the number line makes more sense, at least to me, than the square or the rectangle 1 miles did, because it looks like a distance. I'm saying, okay, she's going from here to here, and I like seeing the distance on the number line. Kind of makes it look like a distance. So I would probably, if it were me, I would probably pick this strategy to do this problem. And if I were trying to communicate, illustrate, do a question like this in the milestones, I would probably choose this strategy on this question. And I would probably pick this strategy on this question, if it were me. But either strategy is fine as long as you understand it. So that is how a number line helps us deal with multiples of unit fractions. If you need to go back and watch any examples again, please do. Once you have nice, neat diagrams out to show you that you could review, then you're all set, and I'll see you tomorrow.